nom président de l'Université fédérale de la technologie Akure, FUTA, et les administrations, les doyens, les étudiants partout. On salue monsieur le professeur Akure, le directeur de la capacité personnelle Wascal à Akure, au Ghana. On vous salue, monsieur. Et félicitations pour vos programmes aujourd'hui. En même temps, on salue et on remercie aussi monsieur le docteur Momini Sawadogo, le directeur exécutif de Wascal, qui se retire à Accra, la République du Ghana. On vous souhaite aussi. Merci, monsieur. C'est le nom de l'université partout qu'on vous remercie. Merci aussi. Est-ce que vous avez quelque chose pour nous dire?
Yes, do we have a floor?
Yes.
Oui.
Yes.
Okay, thank you so much. Thank you so much. I want to say good morning to everyone. I want to just before to give my talk respect Dr. Edie asked me to come on his behalf, the executive director, to give some word to the audience. Thank you so much for inviting Wascal. I want to tell here Vice Chancellor Professor Joseph Forte, dear Deputy Vice Chancellor, dear Professor Andrea Fink from Germany, dear Professor Adeiwa, I want to say all protocol observed because I don't know all of us. I want to say appreciate again Wascal, I have to say Wascal appreciation to all of you for inviting Wascal and also for making Wascal in the heart of this big event. Wascal is delighted to participate in this grand big event with the celebration of the 40th anniversary of FUTA, the Federal University of Technology at Akure. Wascal is very grateful for that. We also appreciate the effort made by the Federal University of FUTA on through Wascal to train at least 30 graduate PhD holders for West Africa since the inception. This is a very useful contribution. It is a very great response to FUTA and Wascal to climate change, doing this training, making available the PhD order for all the West Africa. We are very grateful for FUTA for doing that. We want to appreciate really the commitment of the VC for accepting Wascal and also for all the staff, the Deputy Vice Chancellors, all the staff at Akure who accepted Wascal and make visible this kind of achievement for West Africa. We want also to really, we are really grateful also for the team who are working on the ground. Professor Adewa, I want to say good morning to you. I want again to congratulate you for the contribution for making more visibility for Wascal since you are responsible of the graduate school. And even at the beginning, you do a very huge contribution so this program has been hosted by FUTA. We are very also want to express to you and your team the thanks of the thanks of Wascal and also the appreciation of Wascal, and we encourage you for continue making West Africa can benefit from the experts who are in FUTA, the whole experts in Nigeria, the experts also who are collaborating with your graduate school to make to change things and to make available to experts for West Africa. I want to stop here saying that really the executive director of Wascal and entire Wascal are very proud of what is going on in FUTA, and we are very, very grateful. We wish all of you a very success day and for the celebration, and congratulations to all of you. And this is the end of my talk. Thank you so much for being my Thank you.
Mr. Richard Anika Arifano, you're welcome, sir. The University Librarian, Dr. Garamosi, you're welcome, sir. And I would like to recognize and invite to the high table the Permanent Secretary of the State Ministry of Environment, Mr. Ono Pade Olomuda. You're welcome.
The Deputy Secretary of Development, the registrar, our principal officers, the bursar, the librarian, other principal officers here presented, our deans and directors. To save time, I would just start by the that has been put on ground. Now, I'm going to make a brief presentation because our time is very, very critical. We can see some secondary schools are here, but I want to appreciate in particular our the permanent secretaries of the different organizations who are here. It's very important that we collaborate on climate change. At exactly 11:30, the keynote speaker, Professor Dr. Spink, will be speaking from Germany, from KIT, Germany. And so whatever we're doing, we just need to give him access. We'll give him access. So let me just start by going through the presentation. We want to make everything crisp so that we can go ahead. Now today is Wascal Day. Let's say Wascal Day. Wascal Day means Earth Day, Climate Change Day. It's a great day in the annals of the history of this university, the entire West African countries. Now, thank you. We have already welcomed everyone, and in our own way we say a cabo, Salon de Soa, the French version and all of that. Okay. What is the mandate of FUTA Wascal? The mandate of FUTA Wascal is to focus on the understanding of the science of climate change. How does it affect our buildings? How does it affect our lives? In particular, how does it affect the future of our children who are here today, their future? How does it affect our tomorrow? These are the things that we are meant to do, building capacity and doing impactful research. Okay? All right. I'll quickly go and talk about our history. Let's go back a little. This appears not to be working. Let's say that FUTA, okay. Okay, give me the next slide. Give me the next slide. Give me the next slide. Okay. The next one. The next one. We need to be fast. The vision of FUTA is to be the international center of excellence in research delivery in terms of the meteorology of climate science and later fields. So our mission actually is to produce one, well-developed graduates all over the world, and two, build capacity and to do research. Next one. These are especially our mission to predict extreme weather. It will gladden your heart to know that this is the hope of meteorology in the whole of West and even Central and East Africa, as you see soon. So our mandate is to see that whether it is urbanization, agroforestry, hydrology, water resources, rainfall onset, our farmers want today go to school and so on. I mean, go to their school, go to the farm. All of this is determined by weather. And so to provide public awareness is also part of critical services in Wascal. Shall we go to the next one? Now, our history. FUTA is celebrating 40th anniversary because it was established in 1981. And I'm sure those of us who are in here around 1980 will be glad that we have seen this so far. Because the Department of Meteorology and Climate Science is recognized by the World Meteorological Organization, WMO, as the regional training partner, the university training component of training scientists and meteorologists throughout West Africa. In Nigeria, we present we train at the university level. Others can train other classes, but at the university level, we train them. We have trained people from Kenya, East Africa. We have trained people from Western Africa. If you go to Ghana today, if you go to Gambia, all the heads of climate services are from FUTA and they are from the department. I thought you would say kudos to FUTA and kudos to Department of Meteorology. And so you see, there are Gambia, Tanzania, and all this. We are known internationally. Next one. And then you find that our own history here. There was an international competition, and we must acknowledge the role of Wascal, Professor Paul Fleck, Professor Dada Kone, the ED, and all our partners who have been working for us. So FUTA got this center by competitive process. It was keen, but at the end of the day, we won, and it has been a wonderful thing. So on August 10th, 2010, we officially got that. And here in Wascal, we started officially by 23rd of 2012, and the buildings here were commissioned. Next one. The buildings were commissioned. If you look at this very well, you see Paul Fleck, he was the originator of this process, and we worked with him to win this award. Starting by his left was the former VC, and then the registrar, my humble self, Watara. Now, behind him is the second substantive head of this place, Dr. Ogojobi. And then to the right, you see the Deputy Vice Chancellor then, and Professor Omotosho, who was the pioneer head of this place, director. Next one. And so you find that these are the present staff of this place. The next one, we're mindful of time. As you can see, this place was commissioned by Paul Fleck exactly on that day. That is the 13th of September 2012. Okay, 10th day. All right, next one. All right, we have quite a number of achievements. We just mentioned a few of them. One of our achievements is a curricula that is international, taught by international people all over the world. So, and we regularly review our curriculum to explain and to ensure that even as it is done now in Glasgow, that is the committee of parties, all nations are gathered and they have been discussing in Glasgow, and they are running up now. Now the thing is that there are some strategic development goals, and we are addressing goals 1, 2, 4, 5, 12, and so on. Climate, agriculture, and so on. That's our mandate, and we have been doing that. And also 15. So we are targeting the needs of the different sectors, whether it is urban planning, whether it is agriculture, whether it is education. Our efforts are to prepare people, both local and international, regional. So DRP is totally linked to methods of meteorology, and we have been accredited by the World Meteorological Organization and also the NUC. I must say this, our first graduates, please go on. Our first graduates actually came, and they're still coming from all over West Africa. And so far, we have, for 50, have benefited. Maybe our students who are here today will benefit tomorrow. Because that scholarship is a wow. You get your stipends in Europe, you go to Germany, and you have friends. Only one person is allowed to come from Nigeria. And Gambia, Senegal, and so you become international right here on this campus. And so that's our fourth batch, the next one. And then you find the ones you have trained so far, the first, second, and third batches. We have trained at least 50, and they are doing well all over the world. Next one. And then you find that the beneficiaries, Nigeria has been the highest beneficiary of this. Let's go on. And then you find also that, just to showcase the fact that FUTA is at the head of others, even amongst the committee of Wascal centers. See here, this is the batch 5, when the batch 5 candidates were competing. You see, the first batch was 20, the applicants were 20, the next second batch was 35, 50. This year we had over 300 candidates who wanted to come to FUTA. As we speak, people are still fighting. We go to nowhere else except Wascal FUTA. Isn't that great? And so we are at the lead of all the Wascal centers. Our own application was the highest. Let's go on. All our graduates are gainfully employed, and we can talk about the success in alumni employment and so on. If you look at chief methodologists in the ministries, look at scientific officers, look at staff of World Economic Organization, staff of, even at the Competence Center and other postdoctoral, we have been doing well. Okay, so all our staff, all our students have been gainfully employed. In fact, we have problems maintaining them because they are high flyers. Let's go on. Okay, now, the fact is that some of our graduates are consultants to international organizations, such as the World Economic Organization, Intergovernmental Panel on Climate Change, and the World Bank. We just want to say a few of them, so they are heading places. Let's go. And then you find also that we have been training PEP to produce professional personnel to man critical sectors of the economy in water, energy, agriculture, and so on. I want to appeal to our directors and particularly peers here. You need climate change experts to help, because that is what it's all about. And so here we have been bridging the gap by providing climate management solutions to agriculture, water resources. I'm glad to know that there is a project of balance renewal of something, and they have consulted us because they know that according to what is happening now, before you do anything, you need to consult climate experts. How is it going to affect our future? It's important to us. Let's go on. Then you find that in doing all of this, we have been training people in the state-of-the-art climate science. Next one. Okay, so we have been going through this, doing innovative research. Deputy will talk about this after the Deputy Director will talk about all the researches, so you can see that we are to nitty-gritty of everyday life. Yes, let's go on. Then we have several publications. We'll talk about high impact factor publications from the first, second, and now the fourth batches. Next one. We have moderate structures here. Next one. We'll rush through this because of time. Now you find some of the students here, some of our modest infrastructure that we find. Yes, the next one. Then we are reasonably equipped. If you look at the equipment that we have here, we are not boasting, but you find it rare to get it in Nigeria. We have facilities, all of this to make sure that we have a cluster machine that will see a supercomputer over there at the back here. And at the end of this, we want to show our students some of the things they can do to gain access to the future. Next one. And then you find, yes, these are supercomputers. They can run 1,000,000 times more than your highest computers here. Because we are doing climate that is very, very essential that must catch up with 50 or 10 years to come. So per minute, they run 1,000,000 times more than your average computer. Let's go on. Okay, we have infrastructure, and more are still coming. We have quite some infrastructure, more are still coming, online teaching facilities. I must say this, during the COVID-19, in the whole of the university, in the whole of West Africa, in the whole of other Wascal centers, we were at the head. We were teaching online, people were teaching from Germany, from all over the world, while others were saying they cannot do anything. And that's to showcase that we are at the edge of science. Let's go up to the next one. Now, we have a remote library that you can access. This our librarian is here. We'll be happy to see this also. We have some computing facilities also, electronic library and so on. Next one. And then, of course, we have video conferencing. What we're using now is our own. As we're here, you can see they're seeing us all over the world. And the equipment is our own. And we can showcase this by saying that what you are seeing here, they are seeing over there. They are seeing your faces over there. On the if you are on the internet, you can see what they can see. So we are bringing everything together, technology, science, and everything. Next one. Okay? All right. These are some of the facilities also. Let's go on. Let's go on. Let's go on. Some of the facilities. Yes. And then we are socially responsible. During the COVID-19 episode, we had to go around to make sure that our communities are also doing well. If you have not come, we are still coming to you. All right? Let's go on. Our research activities are numerous. Like I said, the deputy director will talk about that. Please forgive me. I'm saying this to Vice Chancellor. Deputy Vice Chancellor and so on. So our lecturers are coming all over the world. They are teaching online. In this same hall, they teach from all over the world. And our students can ask questions and so on. They also supervise our projects. Let's go on to the next one. Okay, so you find that, for example, these are German scholars. German, and one of them will address us today, very soon. These are, all our students have German supervisors, apart from Nigerian supervisors. Interested to know that our deputy vice chancellor is also one of the lecturers and one of the supervisors of these students. And they are all over, they come from different parts and different countries. Next one, just rush through this one. Let's just rush through this one. Let us, now, what are areas of interest? Agricultural meteorology, renewable energy, use of satellites, meteorological implementation, coastal risk management, urban climatology, biometeorology. The things that come when weather changes, the Qatar and all this, we're into even to coronavirus. Why is coronavirus not devastating as it's doing in Germany and so on? Weather is the answer. So water resources, air quality and so on, we're into all of these. Next one, we also can talk about open collaborations. Our collaborations are open for anywhere and everyone across the world. We are collaborators with people in climate change and modeling. We are into climate change and meteorology, agriculture, and so on. So we have collaborators. We are please begging you, our associates, that we can collaborate so that we can, and when we collaborate, we are already international scene. Because as you collaborate with us, you are collaborating with Germans. But Germany is the sponsors of this program. You are collaborating with other West African people across West Africa. You are collaborating with the market women and so on. And this will showcase you as not just a department, not just a director, but a director of many people across the world. Next one. I like to say this, that we're always thinking about sustainability. How do we sustain this program? Germany, when they started this program, 10 years ago or thereabout, they said they would support us for only 5 years. Now they have gone on supporting West African people the last decade or so. How do we progress? We are trying to sustain ourselves by looking at innovative research proposals. We are leveraging on our alumni to increase capacity. We're implementing training programs, medium, short courses, and so on. So we are willing to collaborate with you to develop capacity. I'm glad that we have one of us here from the ministries, from the Ministry of Urban Development, and Mr. Karuba is an alumni. Please, some recognition. Can we see his face? Let's see his face. Come to the camera. They want to see your face across the world. This one, sir. Yes, sir. They are seeing your face now across the world. Yeah. Okay. So that is it. Thank you very much. He's an alumnus of FUTA, and we celebrate you. We also have somebody who's doing PhD, also in FUTA. Can we see your face too, sir? Okay, it's from the Ministry of...
talking about the physical planning here in FUTA.
Okay, they will give us short speeches after the lecture today. So you find that we're collaborating. Please, I'm not too old. I'm only early 60. I'm not too old to earn a degree in Wascal. If you come for even a short course, you can brand that degree because it is international. We are therefore asking you to please let us collaborate. We can train farmers. We can do things for you. So climate change modeling, climate change, extreme weather, climate change and agriculture, and other things. Let's go on, please. Now you'll find that we're already looking ahead. We don't want to talk so much about our strengths, weaknesses, and so on. But when we look at this, looking at the future, we find that we are quite comfortable. And so please, next one. When you look at our spot clock, you find that our strength is much more than our weaknesses. Our opportunities also more than our threats. So you can see that the next one shows that we are growing and we are green. We are climate compliant. We are looking at the future. There are some people, if they are here, I will tell them, if you are working in oil company, your future is not bright. Because in the next 25 years, Germany, the whole of Europe will no longer use our fossil fuel. They are going to use hydrogen energy, which we are also establishing here. They are going to use solar and other energies. So if you are training your son, students, listen, if you are training to become shell something, and it's not renewable energy, you are not looking at the future. The future is bright only when it is green. And so, any one of us who is looking at the future as oil and so on, I laugh at when people talk about Nigeria, oil and all, the Nigeria Delta. Let us look at the future. The future is not about oil. It's not about gas. It's about renewable energy. Let's go to the next one. Okay, the next one. So, in summary, when we look at the past, when we look at the present, when we look at the future of FUTA DRP-WACS, we can say our past has been good and successful. Our present is looking even brighter. Thanks. We salute all the climate change centers in West Africa. All right? You will see something like climate change in water, climate change in agriculture, climate change in this and that. We are the only one doing the science of it. We are the one doing the science of it because of our experts and people. So that's why we can say that our future is bright, our greatness is sure. Say it with me. Our future in DRP-WACS FUTA is bright. Our greatness is sure. Okay, next one. Now, go back. Now, what we are doing is to raise climate champions. We raise climate champions. We want to raise you, students. We are coming back to you. We want to raise climate champions so that you can be. You heard of that small girl, 13 years old, from Norway, who could talk to the likes of Biden and the other world leaders, say, how dare you joke with our future? How dare you tamper with our destiny? The time is now when you must also rise up as Nigerians. You can occupy the world platform. You don't need to travel anywhere. You can do it here. And then you can go to Glasgow anywhere you go in the world. Okay? So, we are raising climate champions. That's our goal here. Next one. And finally, we say, come fly with us. Because we are flyers. Come run with us. Come ride with us. If you want your future to be as bright. On this note, I will say a very big thank you for your kind attention. Yes. Thank you.
Thank you for always being with us. Our dear registrar, we appreciate you, the University Librarian, and the director of the International Center, and every other directors and all representatives of the permanent secretaries from the state. We want to say thank you to you all. The Dean of SPGS, I've cited you to thank you, sir. And my own thing, I want to return back to my department after my assignment here. Professor AYP, Adifowoje, I'm calling you full. Thanks, sir. So I'll quickly, my I and my director couldn't exchange notes, and so he has actually spoken loudly on most of what I'm to talk about. So my assignment should be easier. So I will be talking on Wascal partnership and projects, and looking in the line of multi-sectoral collaboration, having dignitaries from the ministries and government agencies, and even our own internal government agencies, like my brother, the director, Sesra, is here. So we are looking in the area of multi-sectoral collaborations and scholarship opportunities, which some have been mentioned. Let's go on with the slide. And I want to start from the multi-sectoral collaboration. And this is an area that we are keenly looking towards, because no matter how strong you are, you can't stand alone. So the more the merrier, and when we come together, we can actually do more, like the biblical time that 1 wishes 1,000 and 2 wishes 10,000. That is a very strong mathematics. Only God can resolve that. So we've been collaborating on projects and engaging on consultancy services in our area of strength. And what are these areas of strength that we are talking about? We realize along the line of different sectors. For instance, in the Ministry of Environment, a lot of environmental impact assessments are being carried out. And the issue of even some that are cross-linked in terms of ministries. When urban planning and physical developments are engaging on the project, they are also cross-linked with some of what the environment should actually link. I don't know, maybe there's this synergy at ministry levels. So at that point of environmental impact assessment, we look at the issue of urban draining, carbon control, and even some relative climate extreme issues like flood control. These are key areas where we can work together in terms of development of proposals and actually fostering to get these proposals pushed for grants and work together, as the world is looking beyond this, just an institution operating. This idea of government agencies and institutions working together are the in thing now. So we can actually work in that regard. And coming down to the Ministry of Urban Planning and Physical Development, I don't know, I used to miss it. Is it urban development and physical planning? Urban development. So the issue of climate smart cities has been one of the in thing in recent times. But oftentimes we realize that we are always lagging, particularly African countries, and we can make a difference. Even though many of us from this ministry have travels of conferences, but it ends at the realms of conference. We can begin to talk about climate smart cities. The world is evolving, where a lot, incidentally, my own PhD research was specifically on Akure, and it's on effects of urbanization on climate, local climate, and air quality. And it was at the nick of time when the Akure Urban Renewal Project was ongoing. But it was surprising that that research ends up on the shelf. There's no link, it's of no use, and a lot has gone into that work. And this is the work that actually accorded me several international awards and opened me up to so many travels then. So it's funny if organization like National Center for Atmospheric Research in Colorado sees the beauty of the work and they put their money for you to come, and even the country, the states where it's actually been done, does not even have a know about it. All these are some kind of odds that we think should be phasing out in our own system. Where are the other institutions that we can work together? So in terms of this kind of urban climate modeling, and like I was telling somebody, we can reconstruct. Yes, there is global climate. We can reconstruct. There is reconstruction of climate. It's not construction. And for instance, the proximity between the hottest part of this city and the coolest part is just a function of 15 to 20 minutes trek and about 5 minutes drive. How do I see that from now on? Akure city center remains the hotspot because of the activities and the urban green. And like cities like London, Dublin, and other places that we have seen, what stops us from picking along the line where we can have the urban trees and greens and actually have landscaping? Oftentimes I laugh when I see all these isolated strands of trees being planted and many even being eaten up by termites. I just laugh that even our great grandfathers, they have an idea of this. When you travel through village setting, you see one isolated tree in front of most houses. But we can evolve, thinking along the line of building a climate smart cities. There are a lot of designs that are going into this, a lot of applications, a lot of softwares, and a lot of real programming and coding that goes into this now that we can begin to blend together. And issue of agriculture is another perspective that we can't exhaust it. Everyone is tilting towards climate smart agriculture, and even part of this evolved within the urban agriculture, because there are no other lands to just utilize. People within the context of the urban environment, you can't assume everything is on your roof. And even the walls of fences and buildings are serving as pallets where there are just much, and you see fences that everything is just green within. All these are evolutions that have occurred over time. So we think, and how can you optimize productivity? Is it still doing the agriculture in the conventional way and just going with? Of course, you can reap 1,000 tons of maize from your 6 hectares and still be glad, but the world has evolved. You can as well yield as much as 5 tons rather than the 1 ton you are celebrating. And with minimal expenditure, if you embark on climate change and you engage in use of little resources, it's just a function of some certain climate modifications and having the understanding of when we talk about artificial weather modification, building an ambient environment that gives you the appropriate threshold for survival of whatever, and people can have maize around here. So I think with this, my single slide is where I'm even going to rest it because our time is up. So let's see what's on the next slide. Or before leaving, like I put there, I think that is key for us. We are open to strategic partnership and collaborations that actually will make us stronger. We know we have the strength, but we can't be stronger than this. And because of the students, the next slide, we have Wascal in 11 countries, in ECOWAS member countries, out of which 10 are doctoral programs, and we have 2 master's programs in Cabo Verde, and the other one in Ouagadougou, one in climate change and informatics, and the other one on climate change and marine sciences for the masters. All these are fully funded programs. And you still see students wallowing and languishing and saying, I can't get somebody to sponsor me, I'm intelligent. You have places like this to look up to. And beyond that 2 masters, there's a new 6 masters program that is coming out. 4 are started, and I'm glad you have jumped. I'm glad to tell you that FUTA and Ghana is among the next 2 that will join the 4. And we are bringing it down there again, masters in renewable, renewable energy program, which is also being funded by this German government initiative. So on this, we will still have time with the students. We will talk more after the entire program when we have our own outreach. Thank you. I want to end on this note and say thank you to everyone for listening.
I would like to invite for this presentation to summarize Professor Leo, the director.
Get ready. Prophetically, you are going to be a deputy vice chancellor and later on, vice chancellor. If you like him, say amen. But after the current leadership, no overthrow is allowed. We are not getting ready to have our other host in Germany, Professor Dr. Andres Fink, to come online. As is getting ready to come online, we just want to tell you that we have this collaboration. Andreas, the cloud beside you, behind you, is it cumulonimbus cloud or something? It's looking great. Wow. And we are so happy here. The Vice Chancellor, the registrar, and the entire university is saying welcome. And we also have here the ministries of the environment, urban development. We have people from education. I mean, we're talking about the leaders of the working of the the Planning Act in Nigeria and in Ondo State in particular. We also have here principal officers, deans, directors, and of course, can we see their faces? Some beautiful faces from the federal government college, and some schools. They are also here. They are the classic champions of the future. And so we are welcoming you. Just a sentence to welcome Andres. Andres has been working in the university system for decades. And he's a meteorologist to the core. And you can see behind him is a big system, extreme weather systems. And he's been collaborating with us, and he's been collaborating with us. And so let's join our hands to welcome this big shot from Germany. I told Andreas, I asked them what they want to be in Germany, whether it's going to be Hamburg or somewhere. But I can see that you want them to be in the sky, where it matters. Come and fly with Professor Dr. Andres Fink from KIT, Germany. Andres, you're most welcome.
Okay, thank you, Debo. I hope you can hear me.
Yes.
So let me, before I start my presentation, thank you for the invitation. I feel really honored to be a guest lecturer at this occasion. So all the people in the room, a warm welcome from me here from Germany, from Karlsruhe. And yeah, I hope I can, provide some interesting research results, some interesting ideas that could be the ground for future collaborations with FUTA in Nigeria. So let me start my presentation. So hopefully that works out. And please tell me if you can see the presentation here. Yes. Can I just get a statement? Can you see the screen?
Yes.
Is it Andres? We can see your screen so clearly. It's beautiful. Beautiful, okay. All the way from Germany.
Okay, so I hope the connection will also be good. So far it was quite good. If it's not so good, you may ask that I switch off my camera. So let me start here. So I will talk on present day and future rainfall trends and extremes in West Africa. Actually, I will give a short survey on the research that we did here at KIT. There's definitely other excellent research in the world, but I will focus on work that we did here at KIT in the last 5 years or so. Okay, so so I would like to start with a screenshot of a paper that actually I did with a Wascal PhD, Solomano Sanogo, at FUTA, and also with Professor Omotosho. I think you all know him very well. And this was actually a success story because, I mean, this paper got very well cited in the Web of Knowledge here, and it is on the rainfall recovery from the drought in the 1970s and 80s. So when we did this paper, we used station data, rainfall data from stations, and what you see here, let me change the cursor, so hopefully you can see the cursor now, is we looked at a trend in annual rainfall between the 1980 and 2010, and the red upward pointing triangles give the trend in millimeters here. And if it's significant, there is a black dot in it. So what you see here is that in many stations in the Sahel, there is a significant upward trend. Not so much here along the Guinea coast. And also you see there is some spatial inhomogeneities discernible in the station data. But the general picture here is upward trend, which is significant in the Sahel, and an upward trend, but not so significant here at the Guinea coast. By the way, we did that with the non-parametric Mann-Kendall test, and magnitude was estimated with the same slope. So when we looked into the more extreme rainfall here, so we used the famous ETC-CBI parameters. So that these are the days here with rainfall of more than 20 millimeters. This is actually the total rainfall at days above the 95th percentile. Then you see here a very strong upward trend in the Sahel here, and it is really very, very highly significant here. Whereas when you go to the Guinea coast here, the trend here in the days with more than 20 millimeters is not significant. It is significant here for the rainfall at days that have rainfall above the 95th percentile. So we do see a trend, upward trend in mean rainfall, but also in the more extremes. And one here point is at the Guinea coast where the trend was insignificant. We still have a significant trend in the most extreme rainfall events, daily of course. And then we look into the changes in the onset, cessation, and length of the rainy season. I won't go into detail. We used two criteria. One was a famous one after Wang and Linho used in the 5th assessment report, and the other criteria is a simpler one used by Agrinet. And what we found is that we also found an increase in the length of the rainy season. Here you see that here. It is significant in the Sahel, not really strongly significant at the Guinea coast. And this change in the length, according to these criteria, was mostly due to a strong, extension of the rainy season. So the length was due to a later cessation. Okay. So, but we started in 1980, and this is work I did together with Sean Nicholson and Chris Funk. And so here we looked at the instrumental record here all over Africa, and you see here I encircled the Sahel region in D here, and the Guinea Coast region here, the E. And so the first stations start in the 19th century. And when you look into the Sahel, first of all, there is a significant trend between the mid 19th century and 2014 here, a downward trend, but largely due to the drought that struck the Sahel in the 1970s and 80s, which was unprecedented in the instrumental record here. But you also see that in the 19th century, around 1880, there appeared to be a very wet period, which was even wetter than the wet period in the 1950s. So we do see strong decadal variations. So of course the recovery that we saw recently, which you can see here a little bit, you should not ascribe it necessarily to the climate warming, but it could also be simply due to the decadal changes in rainfall in the Sahel and at the Guinea coast. So we looked in another paper in 2018 a little more into West Africa, and also we had very long records, 161 years. And the point I wanted to make here is, which might not surprise you, the annual trends here in the Sahel are determined by the rains between July, August, and September, so not in the years and the months before and after. And when you go to the Guinea coast, you see different trends here for this, October, November, second rainy season. You see an upward trend. I covered this later. But in the first rainy season, April, May, June also belongs somewhat to it. We don't see a strong trend. So overall, the upward trend recently in the Guinea coast was not very strong, and if it was largely in the second rainy season. By the way, this dashed line is a sort of a shift in the regime. I will not explain it in this talk. Now, coming back to the Guinea coast and the trends at the Guinea coast. In a recent publication, we tried to answer the question, is air pollution impacting on rainfall? Is air pollution perhaps decreasing the rainfall in the populous, Guinea coast area? So in that study, we first identified oceanic forcings that explain a large variance in the, rainfall. We looked at the little dry season, here is the period, the second rainy season, and we used a multilinear regression model. So what you see here in the top two panels is actually which factor explains the largest, part of the rainfall. And you see here this yellowish color. We used here Schills and station data, by the way. The yellowish color points at the Atlantic 3 region, which is, in the equatorial Atlantic, is the large, impact factor on rainfall in the dry season, also in the second rainy season. But there are some stations and grid points for which you should use all the indices listed here or some more indices. And this is the correlation here, which we got from our multilinear regression model here. And the correlation is high and mostly significant. And so the idea was to remove these factors and rainfall and look at the remaining trend at the Guinea coast. And we did that for the little dry season. We removed the oceanic forcings to obtain the residual trend. We did that for a longer period, 1983-2015, and a shorter period. And what I want you to recognize is this is the total trend here. By the way, this is the coastal region we particularly looked at here. And if you remove the oceanic factors, we do see a stronger drying trend here along the Guinea coast. And this is even more pronounced in the last, let's say, 20 years or so. And we had a similar finding here for the second rainy season. But you can also see, look here, that if you remove the oceanic forcing, there is a stronger drying trend appearing at the coast. And in this publication, we provided other evidence that the air pollution, the dimming of the sunlight, actually inhibited the formation of rainfall systems. It's not proof, it's evidence, but evidence suggests that there might be a trend related to air pollution directly at the coast. So, and then, sorry, I have problems. With Sharon Nichols and Chris Funk, we again looked into a extreme rainfall, period, and looked into the causes, the meteorological causes, and that was in October, November 2019. And what you see here is the percent anomaly. The long-term mean was 1981 to 2010. And what was, striking is that we have, positive anomalies almost everywhere, with very high positive anomalies, for instance, here in the Sahel region, also in part of the Guinea coast, here in the Greater Horn of Africa region, even more pronounced in November. So, of course, when you see in the Sahel here, rainfall at that time of the year, the mean rainfall is quite low, so there must be, again, a very late end of the rainy season, a very wet October. It was a juxtaposition here of factors favoring rainfall that caused these extreme wet October-November 2019 period. And in a recent paper together with a colleague from Sudan, we concluded that we do see more debilitating floods in the Sahel, so associated with the stronger rains. Here this is the daily water level at the Blue Nile in Khartoum in Sudan. Here there was a record-breaking flood in 2020 here, which we describe here. Yeah, and this is the hydrograph of the Niger River in Niamey, and you see here the 2020 flood here in August, September was a record-breaking one. So the reference hydrological normal here is this black here curve, and when you look to the green curve, just a year before, we had another, record-breaking flood. So definitely we see that, and the human intervention in the physical environment and poor urban planning is also a major factor here in causing these flood events. Okay, so let me look into another paper here, again in terms of trends, more rains, more intense rains. So this is a work that I did with Chris Taylor here, and we looked into the percentage coverage of cold mesoscale convective systems here in Africa for all months here of the year here, and the trend in these MCS coverage is in blue, and you see here there's a strong trend here in February here to the south and north of the equator. There is this famous trend in the Sahel in August that Chris published in an earlier paper. But overall, there is a trend towards a larger coverage of very cold mesoscale convective systems in the evening, and this is associated also with a stronger African easterly jet. Here the green contours, and this is also related to a stronger contrast in temperature, at least outside the full monsoon season here in the pre-monsoon seasons between, let's say, the Sahel and equatorial regions. So we have enhancement of temperature gradient, we have stronger African easterly jet, more shear, and colder MCS. So a first summary here in terms of trends is we have a clear recovery from the Sahel drought. However, the warning is we have decaying variations, and we should not, naively ascribe this to the climate change, since we had previous wetter periods in the historical record. We do see a trend recently towards delayed cessation of the West African monsoons, with the extreme rains in 2019 being a good example, but this is interesting because it is consistent with projections in CMIP5 and CMIP6 that we see a delayed cessation. We have indications of more intense rainfall here at the daily timescales, also in a region where the recovery hasn't been very strong, and this would be somewhat consistent with the Clausius-Clapeyron scaling idea with the warming patterns. One result that I showed you, there might be a trend at the Guinea coast that reduces rainfall, but that is not related to the greenhouse gases, but due to the air pollution. Also, by the way, I didn't mention that, biomass burning in the southern hemisphere. And all of this definitely caused more intense rains, and with human factors caused an increase in debilitating floods, especially in the Sahel. So now I want the rest of the talk. I want to give a short, review of what we did on extreme events and how extreme events might change in the future. So we have done case studies on two, extreme events. One was the famous Ouagadougou case, 1st of September 2009, with 261 millimeter, which actually mostly fell in the morning within 6 hours. Another case actually was for Nigeria, Abakaliki, in 2016, where we had 223 millimeters in 24 hours. And I would like to start with the WACS case, but before starting with it, you all know that one of the typical rainfall systems in West Africa is a squall line. So a squall line usually propagates westward at 50 kilometers per hour, and it is related to certain environmental conditions, like we have here the low-level monsoon flow, we have the easterly flow and high wind shear, and the high Cape values are realized by the lifting here of the warm and moist monsoon air here with the cold pool, so the convective inhibition is reduced by this. But my point here I want to make is this system, because they are fast moving, they usually give rainfall between 20 and 70 millimeters, but not 200. So my argument is here, this classical systems, if they don't, decelerate, getting less fast, they won't give these high amounts. And so going back to the WACS case here, we had some rainfall stations, we did an interpolation, and actually this was the rainfall on the day before WACS was hit by the rainfall event. And so you see, okay, it was between, let's say, 20 and perhaps 50, 60 millimeters. And this is here a satellite image at 150 gigahertz. You can easily see the high ice water load in the deep convective clouds. And this is, a typical shape of a squall line. But look here, that's in the morning. It starts, here with this bending here. There is a strong rotation, which actually led in the end to the strong rainfall. So this is a little later, 1 hour later. There's also here a second system appearing behind the squall line here, which took over at 9:45. And so the total rainfall on that day looked like more a bullseye here, with 200 millimeter at 2 stations here, and 5 stations had more than 100 millimeter. So the unusual event was that there was a squall line, but there was a second system forming immediately behind here, so 3 hours later, and the succession of these two systems brought the 200 millimeters. So this is untypical, but it was associated with a very strong, we called it moist vortex. It was an African easterly wave here. You see here the moisture flux with the streamlines. There was an extremely high total crystal water content that was really record-breaking in the era interim. At that time, it was higher than the 99th percentile. And this vortex caused a swift refilling of moisture after the first squall line by this strong moisture flux. And so the convection was also synoptically forced. It was in the morning by an African easterly wave, and it did occur in a low Cape environment. So this is a view on the African easterly wave that were associated with the event. So here is a Rothmüller diagram going, here the 25th of August. Here we have 5th of September. The event occurred here with these AEW2. And so the numbers here give the speed of the African easterly waves in meters per second. So the previous wave actually slowed down. So it moves usually in this direction toward the west. It was certainly instrumental in already providing a very moist environment. And there was another slowing down here. This is the longitude of Ouagadougou here. And so definitely these waves were very important. And we checked actually the second wave and found it to be the strongest wave at that time in the era interim data. So the strong rotation was provided by a very strong African easterly wave vortex, which allowed a swift refilling of moisture by occurrence of the second MCS behind the squall line, and that was very important. A similar thing actually occurred with the Upper Kaliki. So this was in 2016. You see here the rainfall in 24 hours here. And we tracked the system back to the Darfur Mountains in Sudan. And you see here it developed into a classical squall line. This is again, by the way, this 150 gigahertz microwave here imagery. And when it, arrived over Nigeria, we see here the Upper Kaliki. Again, we found that it turned into this rotating moist vortex. So let me show you the next slide here. So what you see here, again, is the total crystal water content. Again, very high. We had a very high moisture convergence indicated here in red, above 100 millimeters per day. And also these vortex type system which slowed down here. It was a fast squall line. It got a vortex, it slowed down, very moist, and that led to the strong here rainfall at Upper Kaliki. By the way, it also provided more than 100 millimeters later here at Abidjan. So again, a second summary. So we looked at the Akure case. I did not show it here, but it had a return value of 14,000 years here. It was associated with the strongest African eastern wave in terms of relative vorticity in the period given here in era interim. It led to extremely high moisture flux convergence and column water vapor. And we suggest here that the moist vortex, distorted the classical squall line dynamics and allowed for the two successive mesoscale convective systems passing over Ouaga within 6 hours. And a similar moist vortex developed over southeast Nigeria, causing one of the largest 24-hour rainfall at the Guinea coast. So, what does it mean for the future? Is that potentially a future climate normal, these types of rainfall events? So there are arguments in favor of this hypothesis. For example, the so-called Clausius-Clapeyron scaling means that, with an increase of 1 degree Celsius, we have 7% more water vapor over the global oceans. We have to assume that relative humidity remains constant. Therefore, I point to the oceans. And locally and regionally, this can lead to the same increase in extreme precipitation rates. But we do know that in smaller convective events, smaller scale, and due to changes in drivers like African eastern waves, there might be an increase in extreme events of 13% or more. It's called in literature super Clausius-Clapeyron scaling. Yeah? Also, there is some literature that at least claim that the northern, mostly dry African eastern waves intensify and get more frequent. We do not know what the vortices is that usually travel along the Guinea coast. But all in all, there are some arguments that hint that future rainfall events of the type that I described for Ouaga and Upper Kaliki could happen more often in the future. Now, one step back to the latest IPCC report. And when you look into the IPCC report, you see, figures like this, the change in precipitation here, It is for the SSP 5 to 8.5 year scenario. It's relative to 1981 to 2010. And you see, we see, moisture, Central and Eastern Sahel. There is a more intense rainfall at one day, daily rainfall. This year is a, projection of river discharge and the shoreline position, all of which would, alert people in terms of, having more floods in the future. But how reliable actually are these projections? And here, certainly, I have to give you a warning. I put that on the next slide, because none of the models that went into these figures resolve a squall line or a moist vortex in the way we observed it in the recently. So, what could be pathways to solve the problem? Can we, learn more about future convective systems in Africa would look like? How will the extremes develop? Of course, you could do future time slices with convection permitting models, so sort of a downscaling. The advantage is that you get a relatively robust participant. And this has been done with UK colleagues in their CP forums. Yeah? The disadvantage is that computationally it's very costly, and still, for example, trigger mechanisms of the system are not resolved that are in the boundary layer. So there's still tuning associated with that. There's a recent paper by Cornelia Klein here, and she did a scaling of the 95th MCS rainfall percentile that is observed with resolved changes in the drivers. In this case, it was not FEC waves, but shear and water vapor content. And they found that the so reconstructed hourly extreme rainfall over the Sahel increases, by 37 to 75%. The mean is 55. And this is considerably more when you would only look at daily rainfall in the CMIP 5 models. By the way, I made a mistake. This 95th percentile refers to a projection to the future rainfall. So this is already alerting us that CMIP 5 and also CMIP 6 models will not give us a good answer in terms of the extreme events. Yeah? But I mean, the point here is an Afghanistan wave in a CMIP 5 or CMIP 6 model well represented in the year 2070? Or does the model have a bias in the drivers, and you would not resolve that? And another point is you could also do some so-called pseudo-global warming studies in which you use also convection permitting models, but the idea is to resimulate such a present-day event under future conditions, a moister world, a warmer world, and look into the processes more to understand how a future system could look like. We planned such a thing in the Wascal project Fury Flood, which has just started, and this is my penultimate slide, I think. So we will do that. We will do that in an interdisciplinary approach with many African partners, because if you want to assess the risk, you need the human component here. And so you see here that we have 5 universities in West Africa working in this project. Yeah, and this is actually the reference here. So that was, as I said, a subjective overview of the work that we did here at KIT. And my hope is that this talk is a foundation of future collaboration with Wascal and FUTA. Thank you very much for your attention.
Thank you very much. For the moderation of questions and answers, Dr. Bode Imolayo. Before then, I would like to recognize the Deputy Vice Chancellor Academic, the Dean School of Agric and Agricultural Technology, Professor Mrs. Oluwatoyin Waramati Oshitansi. You are welcome.
Okay, thank you, Professor Fink, for the very brilliant lecture delivered. I must say I'm very impressed, and I know you cannot give us anything less than a very good and constructive lecture today, which you have done. Thank you once again. Please, I would like us to give him another round of applause. So as we all know, during the lecture, he has taken us through different aspects of the topic, which is the present day and future rainfall trends and exchange in West Africa. And part of those areas Professor Fink talked about is on the rainfall recovery, the possible roles of air pollution on rainfall, flood events that is causing the devastating impacts on the socioeconomic activities, as well as trends and exchanges in rainfall activities. So at this juncture, we are going to invite our participants from the Ministry of Environment, from Ministry of Education, Urban Development and Physical Planning, and other ministries, as well as our participants from schools. We have here Federal Government Girls College, Akure, Sacred Heart Secondary School, Akure, and also we have Oyemeku Grammar School. So this is your time to ask Professor Fink questions related to the lecture delivered. Thank you. So also, just to mention that those participants that are joined, that are participating with us here via the Zoom, you can as well drop your messages on the chat box. We will take them accordingly. Thank you. So do we have any question for Professor Fink?
Vicky Olubbe from Federal Government Girls College, Akure. I want to ask the meaning of strong moisture flux convex. You said it happens in Benin, so I want to know what the meaning is.
Strong moisture convection means. So that's a question, if you get it clearly.
Okay, so what is the role of
strong
moisture convergence, or was that correct?
Yes, the role of strong moisture convergence.
Yeah. Okay. Thank you. So actually, to explain this, so of course you all know that with the southwesterly monsoon, moisture is transported from the Gulf of Guinea onto the land. And it needs to converge, it needs to accumulate in the vertical column, in order to fuel the rainfall. So the prerequisite for strong rainfall is strong, moisture convergence, accumulation of moisture in the column above your head. And so that's why we diagnose the moisture convergence and not the moisture flux. It's a necessary, let's say, condition for extreme rainfall. Maybe that answers your question.
Thank you, Prof.
very much for your wonderful presentation that is also very technical. I would like to ask two questions. First, on the rainfall recovery over the Sahel. First one is you have linked it with African Easterly Wave in a way, but I want you to enlighten us from your work if you want to attribute the changes that is occurring in Sahel. Is it more to natural or more to anthropogenic? Then, I also want to find out that the increase in the rainfall in Sahel, does it translate to more length of growing season, or does it concentrate and then you have more extreme and shorter length of growing season? Thank you.
Then, this was time I could, cover. But there is somewhat of a consensus. The rainfall recovery was largely a natural recovery due to changes in the water temperatures in the Atlantic Ocean. However, the intensity of the rain, so the daily rainfall extremes, they are more likely attributed to the warming, the atmosphere holding more moisture. Yeah? So, but that being said, it's not that the recovery is entirely natural. So there is a paper by Spanish colleagues telling that 20-25% is the contribution of the global warming. In the future, by the way, it might be a different story. So the future enhancement of the rain, according to the IPCC latest assessment, is due to the warming. But the recovery is more sort of being a natural decay or more than, let's say, 20-30-year recovery. So now the second question, if I got it correct, is what impact the recovery has on, I think, growing season, on agricultural yields in the Sahel. So that is much more difficult to answer for meteorologists, because we saw that in the recent years there have been more rains, but they have been more concentrated, and that is also consistent with our understanding of the climate system. And so these more concentrated rains can also cause damage to crops due to flooding. So I'm not in a position to answer the question if the net effect will be beneficial or not. I would think at least the rains, can refill the aquifers, and so there will probably net a more positive impact. But again, I'm a meteorologist and not an agronomist.
Thank you. So, do we have...
During the presentation, he talked about how air pollution at the Guinea coast potentially reduce rainfall locally. I want you to expatiate more. How air pollution can reduce the rainfall globally at the Guinea coast. And likewise, I want to ask again, is it only human factors and intense rainfall that can really cause flood in the Sahel Desert? Thank you.
Question. So there was a big project called DRP-WACS, an EU-funded project, and we looked at the impact of air pollution on clouds, on especially low-level clouds that cover the Guinea coast area in the rainy season. And our finding was that the air pollution, the primary effect is a direct effect on a reduced incoming radiation. Yeah? And this reduced incoming radiation, reduces, let's say, instability, so there is the atmosphere is less susceptible to convection, to rainfall. So it's sort of a dimming effect of the air pollution. There are other studies in China that have shown this, yeah. And the problem we had in the project, there is no observation of air pollution, and the models are imperfect. So we gave a list of evidence that this dimming of the incoming, solar radiation would reduce rainfall in the, in direct neighborhood of the Guinea coast. Yeah. So, and your second question was to the human factors. So in that paper with Navi Elagis, in which we looked at a big flood event in the country of Sudan in 2020, of course, the human factors are that people, settle in flood-prone areas. There is no urban planning, and this is one definite human factor that causes, more impact of riverine flooding. There are, of course, others like the land use, and so the increased, let's say, impact of floods, they have a human component to it. That's what I wanted to say. It's not only climate change. that affects the impact of floods.
Okay, thanks.
In the old geography, the closer the environment is to the coastal region, is expected to attract more rainfall. But due to the climate change, where there has never been heavy rainfall like Sahel, the environment is now attracting more rain than even the area in the coastal region. Can you advance what could have been the causes and the consequences of this change in recent times? Thank you.
Yeah. Okay, this is a very good question. Thank you for asking this. So I tried to give some, explanation for this. You are right. So when you are at the Guinea coast and you look into stations at the Guinea coast, they have in the past had rainfall events, let's say above 150 millimeters, because the coastal environment is moister. We have also a land sea breeze system there, and in the Sahel we rarely had that in the past. And my argument here is that the larger moisture in combination with these rotating, vortices in the atmosphere with acting easterly waves, that they led to rainfall systems that we have rarely observed in the past, that allow for more moisture convergence, so the moisture flows together in the Sahel, and the systems are not, propagating that fast that they can dump more rain at a given location. And this is the evidence we see. There is no proof yet that this will be a trend for the future, but it should be alerting all of us that this could be a trend for the future. With having answered this question, I just want to end that I understood that this is the last question. It was a very honor for me to give this lecture and asking giving answers to your questions here on the occasion of the 30th anniversary of the FUTA here in the Wascal DRP. Thank you very much.
Thank you. So now, in the interest of time, we would like to move to other agenda in the program. But before we go, I would like to once again appreciate Professor Fink for the sound lecture delivery and also for